All right, so we're going to look at the network problem questions. Now, I did have number 38 circled, sorry, and for some reason they're not circled on here. So it's number 38 and number 40 were the problem questions of last year. Now, what I think here we've got with question 38, I think we weren't as good last year at identifying where a dummy is on the table, but now we do. So if you have a look, you've got a precedence table and you have to pick which graph underneath shows it. So remember, it is always good to highlight those dummies so where you can see it. So here, if I have a look here, I can see we're looking for repeated letters. So I can see F is repeated there. Now remember, we said when we have a dummy, when we see that, we know it's from the end of F, from end of F to, remember, it's the start of where you see the double one. So to start of G. So you know that for a fact. And so then if you look down and have a look to see if you can see a dummy, one that has a dummy from the end of F. So can you see that one doesn't have one, does it? End of F. This one, the dummy's not at the end of F. This C is, but the end of F to the start of G. No, sorry, this is not, no, it's not doing that. Now, this one, end of F to start of G, yeah, that's sort of working. So I'm going to look at that, and then I'll look at this one, end of F to start of G. Okay, so they both have that dummy. So then the next thing, let's have a look at just what is different about this situation. So if I look at, say here, this is G. If I said G, it means its predecessors are F and C only. So if I look at this one, oh, that's the same. So that's probably not a good difference. What's something that's different? But if you look here at H, it's saying H has F and C as a predecessor, where this one is saying only F. So if we look up there, let's have a look at H. H only has F. So can you see, well, I'm going to go with that answer. Does that make sense? Yeah. So we can see that. So I think actually this cohort, you guys are going to be a lot quicker. Okay, so when we have a network below that shows the one-way paths between the entrance A and exit H of a children's maze. The vertices represent intersections of one-way paths, and the number on each edge is the maximum number of children who are allowed to travel along that path per minute. So cuts on this network are considered possible for the flow of children through the maze. The capacity of the minimum cut would be. So this is just, you need to find maximum flow. We don't really do the cut method. Remember, we do the method of, we start at the top and we work through. And it actually, if you do that method, it sort of can make the next question 40, which was the problem question, easier to do because you've sort of looked at it. So remember, we're going to think about, we're pushing 10 through here. So we start and it can go along there and then it can go along out to the exit. So really I've taken 10 and 10 has been used throughout those pipes. So then if you look, if we do say this, if we go along the next one, so 12 can push out through here. Now I can add 2 more into that. So I've added 2 more. So really I've used 2 of that 12. Okay. So then if you look, I'm going to start crossing this is pointless now. We're not going to go down there because this one's 12 already. So nothing's going to flow into that. So let's just cross it so we don't use it. Okay, and then let's have a look. So now I have 10. Now I'm always trying to take the highest option. Now this guy's going backwards, so I have to go down along there. So I've dropped to 4, and I've got 4 along there, and then 4 along here. So I've used 4. So I go through there and I've used 4 of the 10. All right, now I can push, so now if you think about it, I've still got, if I'm still using some of this 10, I could push, what have I got? I've got 6 left, but it comes along and it could go along here, which means it's dropped to 5, and that means there's 5. So I got 5 through there. So I'm just going to say 5. This was full, and I've added 5 there. So now that's complete. I can't. So I'm going to do the last one of, say, this 8. So 8 comes pushing through. Now there's only 2 more left here. Yeah. 2 more left. It can't go up that 4. It's already full. So plus 2 plus 2. So I've used 2 of them. All right. So then you look at your end bits of what you, so I'll just highlight it. So we used 12, we used 4, and we used 7. So what's that? That's 12, 16, plus 7 is 23. Yes? So there's our answer, 23. So somewhere in there's a cut that does 23, but it's much easier if you do this, because when we go to the next one, it says one path in the maze is changed. Which of these 5 changes would lead to the largest increase in flow from entrance to exit? So if you have a look, I'm going to just highlight them and have a look at it. So it said increasing the capacity of CE to 12. So I'm going to go look where CE is, and I'm probably going to highlight it. That's this way. So it's increasing it to 12. Is that right? Yeah. So if you look at what could it add into? So if it increases 12, it could push out 4 still that way. And then if you look, what have I got? I've got, how much spare have I got extra in that here? So if you think, all right, I've got 12, I'm already at 7. It could add 1 more there. Would you agree? Yes? So it'll add 1 through the last pipe. So it, through the last, 8 pipe. Just so you can see what I'm doing. So that one added 1. Doing that adds 1. If I look at the next change they told me to, they said increase FH. So FH becomes 14. Yeah. So because it only has 4 leading into it, so there's nothing. It's not going to make any change. So that one is going to make no change. So no change. It doesn't do anything. I can see it doesn't adjust anything. If I look at increasing capacity G and H, so G and H to 3. Now, if you look, to 16, if you look at it, that will add, because I've already got 12 going in there. So here I've got 10 came through. So I've got 5 extra I could put through, but I'm only at 12. So we're going to say, so what I'm talking about here is the green. So 15 was coming through. We said it was 10. So now, and I've used, say, 2 from, so at the moment it's got 12. So if I add, I've got 5 more from here that could come through, but they're now saying it goes to 16. So how much more can it push in? So, yep. So say 3. No, sorry. 12 plus, I've only got 5 to spare. So I can push another 3 through here. 16, 15, yeah. Because this only allows 15 to go through. So it'll push another 3 through there. Okay, so let's go. So here we go. So that one will add 3. Okay, reversing the direction of CF. So where's, oh God, CF. So CF would mean that it's going to make it now have flow go through. So if I change that, there's no problems with shoving 6 through there into that one, and we can get it from here. So I'm going to say that is adding CF is going to add 6, so that's fine. That'll increase that. And then if you look at the last change, sorry, I don't know, this one, GF. So GF is getting reversed, which is, where's G and F? Here. So GF is going to be reversed. So reversing GF actually allows, we could push, because it's going to change the 10, so we could actually push 10 through here. So then we know, and 10 out here. So original 10 could have come through there. We could also, this 12 could have filled this guy up. So we are actually going to see 10 and 12. And so we only had, what did we have through there? We had 12. So we've added 6 here. But then we also are able to add more through, because we use the 10 up here, so we can fill this guy up as well. So we end up with a maximum of 30, or so 30 can come through. So we know it's add 7. So this one ends up being